Okay, I'm not very sure about the correct, if the year is correct here, but we're just here to solve. So to prove this identity, you can use both methods to get the other. So you can use this one to get this. If you want, you can use this to get this. But I think using this is much easier if you can see it. I'll use both and you'll be the judge. So this one is 2 sine squared theta. I want to use this identity, cos squared theta plus sine squared theta is equal to 1. And then I want to have an expression for sine theta 1 minus sine theta. So now to do that, I can just take the cosine to the other side and the sine this side. So we can say we take the cosine this side and then the one this side. This side will have sine squared theta minus 1 is equal to negative cos squared theta. So I can write this, the numerator there, in terms of sine squared minus 1, and then substitute it with this and manipulate. Let me show you what I mean. 2 sine squared theta is the same as sine squared theta plus sine squared theta. Because when I add these two guys, I'll get 2 sine squared theta. Then minus 1, everything over sine theta cos theta. Yeah, so now after you do this, as you can see, this part here is the same as this part there. So where there is this, we can write negative cos squared theta, so that we have sine squared theta minus cos squared theta, everything over sine theta cos theta. And then next you can just separate them so that you have sine squared theta over sine theta cos theta, everything minus cos squared theta over sine theta cos theta, like this. And then you have 2 sines there, and then you have 1 there, so you can reduce this. Of course, by using the rules of indices, we know that when you are dividing, you just subtract a 1 from the power. So we are dividing this into that. So we have sine theta over cos theta. Others do this. That's okay too, as long as you are not messing the rules up. So you can do the same thing there, and then over sine theta. So as you can see, by definition, this is tan theta, and by definition, this is the reciprocal of this. It's just the exact opposite of that. So this should be cot theta, which proves the identity. Remember, we are looking for tan theta minus cos theta, and that's what we have here. So now if I was to use the other side, I can just write this as sine theta over cos theta. Please, you don't need to do both, just pick one. And then this one will be cos theta over sine theta. You can get the common denominator. This will be sine theta cos theta. And then cos theta here is sine multiplied by that. This will be sine squared theta minus this one there, it's cos squared theta, cos theta by cos theta, that will be cos squared theta. And then since we don't want a cosine on the numerator, as you can see from the question, you want to change this to sine. You can use this identity cos squared theta plus sin squared theta is equal to 1. Just make cos squared theta the subject of the formula, so that you have sin squared theta, this one, minus, where you have cos squared theta, you write this. Make sure you put it in brackets because of this negative. I've seen a lot of students making very funny mistakes because of negative signs. Okay, so we have sin squared theta, negative times 1, that's negative 1. This times that, that's positive. And then we have this. And then cos theta, sin theta. So these two are like terms. You can add them together to have sin squared theta minus 1 everything over cos theta sin theta, which proves the identity. As you can see, this is the required term on the left hand side.